Alright, first thing you do, graph y equals 3/5 x minus 5. You want to graph the line that is the exact same line as this inequality. So what's the intercept? Where do we start? -5. Our slope is 3/5. So that tells us, the 3 tells us to do what? Up 3 and right 5. So 1, 2, 3, and right 5. So there's our line. Now, if you see these symbols, we're going to use a solid line. If you just see less than or greater than, we're going to use a dashed line. So we'd use something like that. Now, is this going to be solid or is it going to be? It's solid. So I'm going to draw the solid line. And whenever you draw the graph, for me, you're going to draw it with a straight edge of some kind. Now, what we want to do is, there's two regions that this line has cut this graph into. There's the first region, which is everything above the line, and there's everything below the line. One of these two regions is where all the solutions are. And the whole reason why we pick a test point is because if we pick a test point and that's a true, and we get a true statement from it, we find out that's a solution, then it's going to be this, every point in there is going to be a solution. So, like I said earlier, pick 0, 0. If you can. 0, 0 is the easiest point to use. It gets rid of all the fractions. So you're going to take y is less than or equal to, the only time you can't use it is when that's on the line itself. When the line goes right through 0, 0, you have to choose a different point. So you can use it pretty much the majority of the time. Very seldom do you get a line that doesn't go through the origin. So that's my test point. So I'm going to put in 0 is less than or equal to 3/5 times 0 minus 5. Now, what's 3/5 times 0? 0. So I get 0 is less than or equal to 0 minus 5. So 0 is less than or equal to -5. Is that true or false? It's false. Now, if it's false, if it was true, I would have shaded up here where the test point was. But since it was false, we don't want to be where the false points are. Yes? Nope. Test point. Always want to use a test point. I want you to get used to using the test point because there will be times when you don't get the line in the right form or it's in a different form, and I want you to get used to this process because there is truth in what you're saying. There is a lot of truth in what you're saying. However, this process of using a test point applies to a lot of different things in math, so yeah, there are different ways. I can look at this and I kind of know that since it's less than, that it's going to be shaded below the line. And that usually happens, it happens all the time. But since I know it's shaded below, I could have just skipped it and did this. But the idea is I want to see you pick that test point. I want to see you plug it in and make the determination. And it's as much for the future as it is for right now. Getting used to doing this type of a process. Is zero, is that less than -5? If you had, what's the bigger number? 0 or -5? 0. It says, but it says here that 0 has to be smaller than that. That's not true. So that's why it's false. Well, you have to get the line. You have to get this boundary line. You have, in order to start the whole system. So you start by graphing the line. So, because you have to know where to cut the graph in half. So you have to get that line on there. And there's another question back there. Test point. If it's false, you shade the other side. The opposite of where the false point is. So you want to go to the other side. If it's false. If it's true, you graph towards the test point. All right. Now try number 3.